Today we're going to look at ellipses. So we're going to look at the geometry of ellipses and translations of them. An ellipse is a set of all points in a plane whose distance from two fixed points in the plane have a constant sum. The fixed points are foci, the plural of focus. The line through the foci is the focal axis. The point on the focal axis midway between the two foci is the center. The points where the ellipse intersects the axis are the vertices of the ellipse. All kinds of vocab there that you need to know. Okay, there it is. The focal axis is, so this is a horizontal ellipse, we could call it, because the focus, the two foci are on the horizontal axis. We can have vertical ellipses too. It's important to know where the center is because that's like the vertex of a parabola, but it's the center, okay? The vertex of an ellipse, and there will be a couple vertices up here and down here too. So you have major axis and minor axis, okay? So this would be the minor axis vertices and the major axis vertices. Okay, so if you have it like this, x squared over a squared plus y squared over b squared equals 1, your x-axis is your major axis. Your foci are at plus or minus c. How do we get c? It's not the Pythagorean theorem. Basically, it's a squared minus b squared equals c squared. Okay? A squared minus b squared equals c squared. And that's how you figure out what c is. Your vertices are plus or minus a and 0. So then your minor axis vertices are plus or minus b 0. Okay? If you have an up-down ellipse, one that looks more like this, okay, this is your equation. Its major axis is on the y-axis. Its foci are plus or minus c. And again, c squared equals a squared minus b squared, where a is the number under the y here because the y-axis is the major axis. Whatever is bigger will be where your A is. Okay, A is always going to be bigger than B on ellipses. Okay, so this is how the Pythagorean theorem relates, except for instead of the hypotenuse being C, the hypotenuse is A. You know, it's a little weird how they did these. Okay, so here we go. How do you work with ellipses? You take and you want the right side to be 1. Okay, you want the right side to be 1. So what would I have to divide by on both sides? You want the right side to be 1. Divide by 36. Divide each part by 36. So you get x squared over 4 plus y squared over 9 equals 1. What's bigger, 4 or 9? 9. So what's going to happen is you're going to have an ellipse that's at 0, 3, 0, negative 3, 2, 0, and negative 2, 0. And the ellipse is going to look like that. Okay? So where are the foci at? Well, c squared equals a squared minus b squared, correct? So what's 9 squared minus 4 squared? Well, that's 81 minus 16, which is 65. So c is plus or minus the square root of 65. So your points where the foci are at 0 square root of 65 and 0 negative square root of 65. Let's see how I did. Uh-oh. A squared minus b squared. A squared is 9. B squared. Oh! Yes. Birschbach. You're a Doomkopf. Okay, if I could take this away. A squared is 9 and b squared is 4. Because a is 3 and b is 2. I screwed up and made I squared the squared. Ooh, stupido. All right, so plus or minus square root of 5. I'll try to do better in the future. Okay, now what did I do? All right, let's do this again. Okay, foci are at negative 2, 0, and 2, 0. What I like to do is I like to draw it out if I'm trying to figure this out. So this is a focus and this is a focus. So this is C is 2. Okay, C is 2. So A squared minus B squared equals C squared. So C is 4. The minor axis has a length of 2. So it's 1 above and 1 below. So B would be 1. So now we got to figure out what A would be. Oops, minus. So if we subtract 1 from each side, because 1 squared is 1, A squared equals 3, so A would equal the square root of 3. So this is at square root of 3, 0. And this is at negative square root of 3, 0. Okay? So what's your equation? Well, since it's a left-right ellipse that looks like this, sort of, it's going to be x squared over a squared, which is 3, because the square root of 3 squared is 3, plus y squared over b squared, which is 1, equals 1. That should be your equation. And if they multiplied everything by 3, I don't like that, but it would be x squared plus 3y squared equals 3. I mean, that would also be a correct answer. 5. Oh, yeah, I'm dumb again. Look at that. I was dumb twice in a row, 2 problems in a row. That's a minus. So what do I have to do to each side? Add 1 to get 5. Jeez, 2 problems in a row. Made a simple little math error. So it should be 5, not 1. Oh. Now, what if the center is not 0, 0? Then you just have an h and a k involved. Okay, you'll have an h and k involved. But it's the same basic principles. So far above, so far below, so far to the right, so far to the left. So let's look at that. Okay, what's halfway in between negative 1, 4 and 5, 4? Halfway in between. 2, 4. So your center is at 2, 4. So your distance from 2, 4 to 5, 4 is what? 3. So A equals 3. Okay, A equals 3. The major axis has a length of 8. Oh, this is a minor axis. So this is B. B has a length of 3. The major axis has a length of 4. Okay? So the major axis is, since this is at negative 1, 4, and 5, 4, the minor axis is left and right. So negative 1, 4, and 5, 4. It'd be like this, where your center is here at 2, 4.
You were right on question 2. It was -9, not -4. Just letting you know.
Okay, thank you. All right, so then your major axis has a length of 8, so it's 4 above and 4 below. So this would be at negative 2, 4. Nope. 2, negative 2. 2, no, it wouldn't be. Be at 2, 0. Because if it has a major axis length of 8, it's 4 each way. And so this would be at 2, 8. So here's our ellipse, and it looks horrible. I'm sorry, but there we go. So what's the equation? Well, it's y minus the y value of your center, 4, over the length of the major axis squared. So 4 squared is 16, plus x minus the x value of the center, 2 squared, over b squared, which is 9, equals 1. Ooh, they want standard form equation. So let's jump to it. Okay. They graphed it like I graphed it, found the center, and then they got A and B, which I did. So then they got that, which is the same as what I got in the last part. I just had my y first. Okay. So there we go. All right. Finally, center vertices focus. Where's the center of this one? Where would the center be? Negative 1, positive 1. The opposite of this, opposite of this. Okay? How far is it in the up and down direction? What's the square root of this? 3. So A is 3. What's the square root of this? 2. So B is this. So this is going to be an up-down one because the y, what's under the y is higher than what's under the x. So your center is at negative 1, 1. You go 3 up from that. 1, 2, 3. It's right here. 3 below that. 1, 2, 3 is right here. And then 2 to the right is right here. 2 to the left is right here. So your ellipse looks like this. Okay? So the center is there. This vertice is at 1, 1. This vertice is at negative 3, 1, because it's 2 each way from there. This vertice down here is negative 1, negative 2, negative 1, negative 2. I know that doesn't look like a negative 1. This one over here is at negative 1. If we add 3 to 1, it is 4. So that's all your vertices. And then to find the foci, it's c squared equals a squared minus b squared. So c squared equals 3 squared minus 2 squared, which is 9 minus 4, which is the square root of 5. Because c squared equals 5, c equals the square root of 5. So it's the square root of 5 above there and the square root of 5 below there. So it's negative 1, 1 plus the square root of 5, and negative 1 times 1 minus the square root of 5 are the foci. Let's see how Mr. Bierschbach did. There we go. There's my foci. Vertices are there and there, which I had. Center is there. Minor axis vertices, I guess they didn't ask for. Okay? When planets orbit around the sun, most of them have elliptical orbits. Okay? We're not going to talk about that. I don't think we are. Discard. So, on assignment manager, enter. Okay, we'll look at a few of the problems that you'll see, so then you have an idea of what's going on. This one says find the vertices and foci of the ellipse. The vertices come from A. Okay, the vertices come from A. There's 6 each way in the x direction. So what would be the two vertices? 6, 0, and negative 6, 0. The foci come from taking c squared equals a squared minus b squared. So c squared equals 36 minus 11, because this is a squared and b squared. 36 minus 11 is 25, right? So c equals 5. So the foci are at 5, 0 and negative 5, 0 because they're on the same axis as the vertices. Okay? And I bet if I go down to the bottom, that's the right answers. Oh, look at that. Mr. Bierschbach has it going on. All right. Find the foci and vertices of this ellipse. What do we do first? We need the right side equal to what number? 1. So it's x squared over 25 plus y squared over 16 equals 1. Okay? Is it going to be left, right, or up, down? Left, right, because the x is higher. So it's going to be at 5, 0 and negative 5, 0 are the vertices. To find the foci, c squared equals a squared minus b squared. So c squared equals 25 minus 16. 25 minus 16 is what? 9. C squared equals 9, so c equals 3. So it'd be at 3, 0 and negative 3, 0. You're supposed to match a graph with a right ellipse. Okay? Now, if it's written like this and this, what do I know about those? Their center is what? I'll zoom in. Their center is what? 0, 0. This is a left-right one because what's under the x is higher. This is an up-down one because what's under the y is higher. And I didn't mean to do that. So these are 0, 0. So this one goes to this one. This one goes to this one. Now, what's the center of this one here? The center is at negative 3, 2. Okay, so that goes to that one. This one, its center is at 1, 2, which is this one. Okay? Knowing the basics about ellipses can get you a lot of these correct. Okay? Graph the ellipse. Well, let's look at the basics of it. Its center is at 0, 0. Its major axis is what? What are the A's here? 7, 0 and negative 7, 0. So we know it's not this one and it's not this one. So it's either this or this. What's the minor axis going to be? 0, 2 and 0, negative 2. So it must be B. Okay. So that's how you do some of these. Let's do the 8, 6. So your center is where? Negative 3, 1. How long is your major axis? 4. Your minor axis is 3. You go 4 from your center to get to your major axis. You go 3 to get to your minor axis. So it's an up-down one. So it's not this or this. Your center is at negative 3, 1. So it must be A. Okay, must be A. I'm going to just let you go on this. Hopefully you do all right. It may take